This is Unit 4, video number 6, net ionic equations. When we have a double replacement reaction that's been completely solved, one of the things we want to do is remove the ions that are not actually reacting in the solution. We call those ions spectator ions because they're floating around before the reaction occurs. They're still floating around after the reaction occurs. So I want to do an example here. I've got aqueous copper chloride and sodium hydroxide. So let's draw out our beaker and see what ions are present in the beaker. Copper here is +2, so copper +2 ion or copper 2 ion is floating around. And I've got chloride floating around in here as well. Let's draw our chloride up. I've got sodium hydroxide, NaOH, so I have sodium ion floating around and hydroxide ion floating around. As the reaction occurs, these are going to mix. Obviously, like charges are not going to interact with each other or repel. So we're going to get copper sticking to hydroxide and sodium sticking to chloride. So let's write those two out. So we're going to have NaCl. We know chloride compounds are generally soluble, sodium compounds are always soluble, so that's aqueous. Copper sticking to hydroxide. Hydroxides are generally insoluble. So we're going to get copper 2 hydroxide, which is a solid. Let's see what that looks like in our beaker. Now we've got sodium and chloride, but they're aqueous, so we have sodium ion and chloride ion. Then at the bottom now, because this is a solid, we built up a little pile of copper 2 hydroxide. Now, when we go to net ionic equations, we're interested in what actually reacted. So in this case, sodium started out as an ion, ended up as an ion. It doesn't have any impact on the reaction. That's what we call a spectator ion. Chloride started out as an ion, ended up as an ion. It is also a spectator ion. But copper started out as a free ion, ended up as a locked-down solid compound. That is not a spectator ion. Hydroxide started out as a free ion, ended up as a lockdown solid compound. That's not a spectator ion. So we want to remove our spectator ions from the reaction. So we're going to take our sodium and chloride and knock it out. So the actual reaction, we call this the net ionic equation, is copper +2 plus hydroxide. Those are aqueous, dissolved in solution, producing our solid, copper 2 hydroxide. Now this has to be balanced, so obviously I'm going to need 2 hydroxides. Should be a fairly simple compound or reaction that we write for the net ionic equation. So the net ionic equation is going to remove the spectator ions, that's the key. Should form a fairly simple compound, especially if we have one solid produced.